Assume I have a signal. This is my signal, let us suppose. Okay. And my signal ranges from say -4 volts to +4 volts. This is my signal M of t. So the total voltage swing from -4 to +4 would be 8 volts. Okay. Now what I do is I divide say this is -3 volts, -2, -1, 0, 1, 2, 3. And I fix my quantization level at say -3.5 volts. I change the color so that my 3.5 volts is the quantization level. -2.5, 1.5, -0.5, say 0.5, 1.5, 2.5, 3.5. This is my M0, M1, M2, M3, M4, M5, M6, M7. 7 levels are there. Now the question is, I take a sample value at this interval of time. I take another sample value, one more. So if I draw the vertical lines, somewhere here I got my first value. Let it be 1.1 volt, let us suppose. So my sample value is 1.1 volt. Now you tell me, what is the nearest quantization level to 1.1 volt?
One.
Look at the figure and tell me.
1.5. 1.5, sir.
Perfect. The nearest quantization level to 1.1 volt is M5. And M naught is minus 3.5 and the M5 is 1.5 volts. So now the nearest quantization level is 1.5 volts. Very good. Then I take another sample. Let me draw the vertical line for this. Let it be some 2.8 volts. Now you tell me what is the nearest quantized level of 2.8 volts. What is the nearest quantization level of 2.8 volts?
M6, sir. 2.5, sir. 0.5, sir.
2.5 volts. Perfect. Now I take one more sample value, which is say about some 3.7 volts. So 3.7 volts is approximated or quantized to how much?
3.5 volts. 3.5, sir.
3.5 volts. Fine. Then let me take one more. So this comes somewhere 3.1 volt. Let it be. It is more than 3, right? Yeah, more than 3. 3.1 volt. So 3.1 volt is quantized to
3.5.
3.5. Then I have one more. Oh, this is more than 2. Let it be 2.2 volts. Now you tell me what would be the 2.2 volts quantized to.
2.5, sir. 2.5.
2.5 volts. Fine. Let it be. This is less than 1. Let it be 0.9 volts. So 0.9 volts is quantized to
0.5.
0.5. Fine. So this is say minus point 2, let us suppose, because this value is less than 0. So minus 0.2 is quantized to which value? Minus 0.2 volts.
Minus 0. Minus 0.
mi- Minus 0.5. Fine. Then here I got some value, say almost the same value, minus 2.5, sorry, minus 1.5. So minus 1.5 volts is quantized to the same minus 1.5. And finally, the last value somewhere here. So this is minus 2.7. So what is the nearest quantized value of minus 2.7 volts?
Minus 2 point.
Minus 2.5. Fine. Now, this is my first level, right? In the color again. This is my first level, second level, third level, fourth level, fifth level, sixth level, seventh level, and eighth level. And these values are, as you said, minus 3.5 volts, minus 2.5 volts, minus 1.5 volts, minus 0.5 volts, 0.5 volts, 1.5, 2.5, and 3.5. Fine. Now what I do is, this is the quantization level. Now I give code number for each quantization level. Let it be 0, 1, 2, binary code, 3, 4, 5, 6, 7. This is my code number. Now if that is the case, with this, now you tell me what is the code number for 1.5 volts quantization level? 1.5 volts quantization level, my code number is
5.
5. So here your code number is 5. For 2.5 volts, it is how much?
6.
6. For 3.5 volts, 7. Again 7. 6. For 0.45 volts, it is 4. Minus 0.5 volts, it is 3. Minus 1.5, 2. Minus 2.5, 1. Now each code number, my code numbers range from 0 to 7. That means each code number requires 3 bits to represent. So this 5 can be represented as in binary 101, 110, 111. So this is my sample voltage or simply sample value, and this is my quantization level value or quantization level, and this is my code number, and this is the binary representation. So this 101 can be represented like this. This is 1, this is 0, again I have 1. Now I have 110, so I have 1, another 1, and I 0. And I have 1, I have one more 1, and I have one more 1. Similarly, 1, 1. The binary representation is now converted into the pulse representation of the binary code. I have a 1, I have a 1, and I have a 0. Now I have 1, 0, again 0, then here again 0 I have, now 1, again 1, 0, 1, 0. Then I have 0, another 0. So this is the pulse representation. Or simply I can call it as this is the